Good afternoon, students. I am Chaitanya, Assistant Professor in Mathematics, working in Institute of Aeronautical Engineer, located at Dundigal, Hyderabad. As a continuum of the concept of maximum likelihood estimation and log likelihood estimation in fourth module, today I'd like to discuss on the log likelihood estimation of binomial distribution. That means we will discuss binomial distribution and some important properties of binomial distribution. Then we will discuss how to calculate log likelihood estimator of the parameter p of binomial distribution. So let us start our lecture. So let us recap the maximum likelihood estimation. The maximum likelihood estimation method is an estimation procedure that, given a probabilistic model, estimates its parameters in such a way that they are most consistent with the observed data. That means when you have a data set like this, say A's marks, marks of B, marks of C, D, like that, you have so many columns, and you want to predict a missing feature which is not clearly visible. Okay. Then by observing the data set, you will prepare a probabilistic model. Say P of X. It might be binomial. In some cases, it might be a Poisson or it might be a normal. And every distribution will have parameters. Suppose it is binomial, the parameter will be P or N. And Poisson, the parameter is lambda. And normal, the parameter is mu or sigma. And in exponential case, the parameter is theta. So in the maximum likelihood estimation, by observing the given data and after fixing the probabilistic model means probabilistic distribution, you will try to maximize the parameter with which you are going to expect the missing feature. That's what it is mentioning. Now, what is log likelihood estimation? Log likelihood estimation is nothing but applying logarithm on the maximum likelihood estimation. Suppose let us assume that we are applying a probabilistic model, a probabilistic distribution on a given data set. Say its function is density function is f of x comma theta. Then we can construct, suppose there are several variables x1, x2, xn which are commonly having the parameter theta and following a probabilistic model. Okay, then we can construct the maximum likelihood estimation function, okay, by using the formula pi I is equal to 1 to n f of xi comma theta. When we apply logarithm to this, then we will get the log likelihood estimation. What kind of logarithm we are applying? That is natural logarithm, that is base e. That is what the first sentence is been mentioning. Okay, now so from logarithm point of view, we have some benefits of log of multiplication becomes addition, and log of division becomes the difference, and log of power becomes again multiplication. So with this mathematical advantages, we generally prefer a logarithm. Okay, now here we can see as a small example of log likelihood estimation, Bernoulli distribution. Bernoulli distribution means it's a trial. It's a trial where only two possible outcomes, namely failure, success or failure. Okay, then the function will be defined as p of x is equal to p into 1 minus q for one trial, because only one trial is there. Okay, so this is called Bernoulli distribution. For this, if you go into the details, for example, there are n Bernoulli variables, n Bernoulli variables means it would be, if you assume, sorry, 1 minus p this is, so if you assume it is theta, then it would be theta power n, okay, into 1 minus theta power n, okay, this is the log, I mean maximum likelihood estimation of theta for Bernoulli distribution with okay, uh, and pi I is equal to 1 to n theta power, you can understand yi, so yi means theta power yi 1 minus theta power yi, okay, or 1 minus theta power 1 minus yi, you can assume. Then when we apply logarithm, automatically it becomes yi into log theta with summation plus 1 minus yi into summation I is equal to 1 to n log 1 minus theta. Okay, so this is the log likelihood function of the Bernoulli distribution with n independent Bernoulli random variables, namely y1, y2, yn. Okay, now let us look into the binomial distribution and its properties. Then we will discuss what is the log likelihood estimate of the parameter p of binomial distribution. Yeah, Bernoulli trial, I already told you, it's a random experiment with only two possible outcomes, namely success and failure. Okay, you can take the example of tossing a coin. Then you will have only head or tail, where P denotes the rate chance of happening of head and Q denotes the chance of happening of tail. So P plus Q is equal to 1. Okay. Now, what is binomial distribution? Suppose we have n independent Bernoulli trials and independent Bernoulli trials. N independent Bernoulli trials means these first n should be finite according to the characteristics of Bernoulli trials, definition of Bernoulli trials, n should be finite, and each trial should have two possible outcomes, namely success and failure, and the rate of success should be uniform for each and every trial, and each trial is independent of the other trial. That means every trial is independent, a new one. The before trial won't affect the running trial, and the running trial result won't affect the next coming trial. So when the number of trials, a set of trials satisfies these four properties, that is finite number of trials, each trial should have only two possible outcomes, success and failure, and success rate is uniform for each and every trial, and each trial is independent of the other, then those set of trials are called Bernoulli trials. Okay, suppose we are having n Bernoulli trials and we want to calculate the probability that we will be successful in xth trial out of n trials. That means we want to calculate the probability of that I'm going to win in xth attempt out of n attempts. Okay, then if suppose under the assumption that in each and every, suppose I have attempted for x times. Okay, I have attempted for x times, and I want to then automatically the probability of being successful in all trials will be small p for x. Suppose there are n trials I am attempting, out of which x times I am successful and n minus x times I am failure. Let me write more clearly. Yeah, out of n trials, x times I am successful and n minus x times I am failure, then success would be p power x and the failure is q power n minus x, because remaining n minus x trials I have failed, so the failure rate is q for each and every trial, so this is q. That means p power x q power n minus x. See, this can be happened, this x successes out of n trials can be happened in ncx combinations. So The definition of the binomial distribution is defined as B of xn comma xnp is equal to ncx p power x p power n minus x. Okay, this is the binomial probability calculation function or probability mass function, you can tell, which tells that if you want to calculate the probability that x times I have to success out of n times. Okay, x times out of to success out of n times. The probability is defined as number of times you are attempting combinated with number of times you want to win, and each trial has success rate p. So x times you wish to win p power x, and remaining trials you are failing. That means n minus x trial. That means q power n minus x, because your failure rate is q. So this is called binomial function. Okay. Now I'm going to calculate some important properties of binomial distribution, and after understanding these properties, then we will understand what is log likelihood distribution of binomial distribution, how the parameter mean of binomial distribution could be calculated under log likelihood, and the best possible value will be again matching with the mean. These things we are going to. First, let us understand what is how to calculate mean of binomial distribution. We know that every probability function has mean as well as variance. We have studied these things in our statistics and probability. So every probability distribution has probability mass function or density function, and hence it will have mean and variance. Now I'm going to calculate, as a first part, I'm going to calculate what is the mean of binomial distribution. First, let me write the formula of binomial distribution over here. That is ncx p power x p power n minus x. Okay, now I want to calculate the mean. That is, mean is also called as expectation. Mean, expectation, and average. All these are all synonyms. So we could understand mean means expectation. That is E of x. Now my question is, what is E of x for a discrete random variable? Because x binomial is a discrete random variable. Okay. And if discrete random variable, the formula of expectation is summation x into p of x. If it is continuous, the formula will be integral x into f of x dx under the limits minus 1. But under discrete case, it would be summation, and continuous case, it would be integration. So when we come to here how many trials? Only n trials. X runs from 0, 1, 2, 3, so on n. X runs from 0 to n. So x is equal to 0 to n. Okay. So what happens? Let us write summation x is equal to 0 to n. What is p of x? P of x is nothing but ncx small p power x small q power n minus x. Okay. Now x is equal to 0 to n. I am not distributing x. Now we have a formula in our permutations and combinations, that if it is 10c 9, it could be written as 10 by 9 into 9c8. If it is if you want to reduce it further, you can write it as 10 by 9 into 9 by 8 into 8c, 10 by 9 8c7. Okay, and you can further reduce it as 10 by 9 into 9 by 8 into 8 by 7 into 7c6. Okay, in this way you can reduce the combination as possible times as. Okay, this is a formula from combinations. So by using this formula, okay, we could understand that NCR can be written as n by r, sorry, n by r, n minus 1 c r minus 1, and further reducing, we could write it as n by r, n minus 1 by r minus 1, n minus 2 c r minus 2, and further reducing, we can write it as n by r into n minus 1 by r minus 1 into n minus 2 by r minus 2 into n minus 3 c r minus. So in this way, you could reduce the combination to the extent that you require. So by using this knowledge of the formula, we are going to reduce this ncx to one step, that is n by x into n minus 1 c x minus 1. Okay, so n minus 1 c x minus 1, and p power x q power n minus x. Okay, now we can cancel x. Then automatically the summation becomes x is equal to 1 to n into n minus 1 c x minus 1. Why it becomes x 0 becomes 1 means because minus 1 factorial is not defined. That means negative integer factorials are not defined. So we have to shift the summation from 0 to 1. That is why 0 has become 1. Now n minus 1 cx minus 1. I'll write p power x as x minus 1 into p, and splitting the power, p power x as p power x minus 1 into p, and q power n minus x, I'm going to write it as n minus 1 into minus of x minus 1. Okay, that means I have written q power n minus 1 minus, because I am adding and subtracting 1, I could write it like this. Now see here, summation runs on x. That means n and p are constant, so n and p comes out. Will be remained with summation x is equal to 1 to n minus 1 c x minus 1 p power x minus 1 q power n minus 1 minus x minus 1. Okay. This is the resultant thing from the previous step. After taking n and p out, constants out, will be remained with this. Only x terms remain inside, and non-x terms, that is n and p, comes outside. Now, if you carefully look at this and if you expand this, binomial theorem in our 10th class proposed by Blaise Pascal, that is a plus b whole power n, that is, nc naught. Suppose I'm writing it for, okay, you can understand it also for nc naught, a power 0 b power n plus nc1 a power 1 b power n minus 1 plus nc2 a square b power n minus 2 plus nc3 a power 3 b power n minus 3, so on, ncn minus 1 a power n minus 1 b plus ncn a power n into b power 0. This is we call it as binomial expansion. Okay, so we know by using this into our mind, that means this can be compactified as summation I is equal to 1 to n nci a power I b power n minus I. By using this, by keeping this into our mind, we can understand this as np into p plus q power n minus 1. Okay, p plus q power n minus 1. Then you know that the success and failure together gives us 1. So this becomes p plus q becomes 1, that is np into 1 power n minus 1, that is equal to np. So finally what we have observed that the mean of binomial distribution, that is e of x summation x into p of x is equal to 0 to n, that is equal summation x is equal to 0 to n x into ncx small p power x q power n minus x. After simplified, we got mean as np. Okay, so you can see the same thing here, which is completely solved in the PPT. Okay, this is the step how we have substituting the function binomial, and we are writing the NCR formula, and we are reducing, cutting the terms and substituting. Finally, again we are reaching the same step, and here it becomes np into p plus q whole power n minus 1, as I told you, by using binomial theorem. Okay, and p plus q is 1, so np into 1 power n minus 1 and np. So mean is np. That is what we have observed. Okay, now I'm going to calculate the variance. Okay, the variance I'm going to calculate. So for that, I'm starting here. I'm going to calculate the variance of binomial distribution. Okay, so variance of binomial distribution. First, let us recall what is the formula of variance. That is e of x square minus e of x whole square. This is the definition of variance in the random variables. That is, if x is a random variable, v of x will be e of x square minus e of x whole square. Okay, now already just now we calculated e of x means mean. Just now we calculated it as np, so it becomes np whole square. So v of x becomes e of x square minus np whole square. Okay, so now our interest is to calculate e of x square. If we calculate e of x square, will be known what is v of x. So e of x square, I am going to calculate e of x square as e of x square as summation x square into p of x. X is equal to 0 to n. Okay, because I told you the binomial function is ncx p power x q power n minus x. X is equal to 0, 1, 2, so on n. So I have written this formula, and summation x is equal to 0 to n x square into p of x means ncx small p power x q power n minus x. Okay, now I'm going to reduce. I'm going to do one small thing, that is mathematical manipulation, that I'm going to add and subtract x. I'm going to add and subtract x to the x square. I'm going to add and subtract x to the x square. Then I'll get this thing as output. Okay, now I'd like to separate the summations. That is, summation x is equal to 0 to n x square minus x into ncx p power x q power n minus x, and summation x is equal to 0 to n x into ncx p power x q power n minus x. Okay, after separating the summation to this into this, we will get this. Now summation x is equal to 0 to n x square minus x ncx p power x q power n minus x plus, here if you observe, this is nothing but p of x. So this becomes summation x is equal to 0 to n x into p of x, x into p of x. Okay, but this is nothing but e of x, the definition of the expectation of a discrete random variable, e of x. But in the previous result, we calculated as mean of binomial distribution as np. Just now we calculated the mean as np. So this becomes NP. So what we are left with? We are left with summation x is equal to 0 to n x square minus x into ncx p power x q power n minus 6. So e of x in the way of calculating e of x square, we reached at this step. First we started with the definition of e of x square, summation x square into p of x, and we substitute the p of x formula n6 p power x q power n minus 6, and we have added and subtracted x, that is x minus x plus 6, and we multiplied this into this plus this into this. Okay, then here we are observing that this is nothing but our p of x, a binomial function. So summation x into p of x, it is nothing but the definition of e of x, expectation of x. So already we calculated expectation of binomial random variable is np, so this is np. Okay, now we got e of x square as summation x is equal to 0 to n x square minus x into ncx, or p of x, you can write it in short, plus np we got. Okay, now I'd like to write x is equal to 0 to n. Here what is common? X is common. X is common means x into x minus 1 into p of x. Okay, p of x means ncx p power x q power n minus 6. Okay, right. Writing p of x, we got ncx. Okay, now I'm going to cut x is equal to 0 to n x into x minus 1. This can be written as, by reducing it to two steps, we'll get n by x, n minus 1 by x minus 1, n minus 2 c x minus 2 p power x q power n minus 6. This is what we'll observe. By splitting ncx into two steps, we will get this, that plus np is as usual. It is continued as it is. Now here x can be cancelled, x minus 1 will be cancelled, because two factors are cancelled. The summation will be moved to x 0 to 2, that is 2 to n into n minus 1 into n minus 2 c x minus 2 p power x q power n minus x plus np. Okay, p power x q power n minus x plus np. Now summation x is equal to 2 to n into n minus 1. Okay, I could write n minus 2 c x minus 2. P power x can be written as p power x minus 2 into p square. That means splitting the power p power x as p power x minus 2 p square, and adding and subtracting 2, we will get n minus 2 minus x minus 2, plus np will be as usual. NP continues as it is. So here the summation runs on x. So n minus 1 p square are constants. So what we are going to get, n into n minus 1 into p square. Okay, n into n minus 1 into p square, summation x is equal to 2 to n minus 2 c x minus 2 p power x minus 2 q power n minus 2 minus x minus 2. Okay, plus np is as usual. So what we get, let me write it in a more clear way, summarize that. We started with e of x square, that is summation x square into binomial p of x is equal to 0 to n. We arrived at the step that n into n minus 1 into p square under the summation x is equal to 2 to n p power p power x minus 2 into q power n minus 2 minus x minus 2. Okay, plus np. Now put x minus 2 is equal to y. You will get putting x minus 2 is equal to y, we will get n into n minus 1 into p square summation y is equal to x minus 2 as y is equal to 0 to n p power y q power n minus 2 minus y. Okay, plus np. Now or else you can easily understand it as, by using binomial theorem directly you can understand it as, you need not substitute anything. With the help of binomial theorem you can easily understand it as p plus q whole power n minus 2. Okay, because binomial theorem a plus b whole power n is summation nci a power I b power n minus I is equal to 0 to n. By using that you can easily understand that this is p plus q whole power n minus 2. So n into n minus 1 into p square. What is p plus q? P plus q is always 1. We know success and failure put together always gives us 1. Okay, so n into n minus 1 into p square, this is equal to 1 power n minus 2 plus np. So n into n minus 1 into p square plus np. N square p square minus np square plus np. So what we get, e of x square is equal to n square p square minus np square plus np. Okay, now let us summarize this. E of x square, we got n square p square minus np square plus np. Okay, now our intention is to calculate variance, that is v of x. Variance is e of x square minus e of x whole square. Already we have calculated e of x as np, so this is np whole square. E of x square, just now we got this, that is n square p square minus np square plus np. Okay, now we could see that n square p square can be cancelled because both are opposite in direction and equal in magnitude. Both can be cancelled and we will get np minus np square. Now what is common? Np is common. Take np out. Then here 1 remains and here 1 minus np square, this is 1 minus p remains. So np into q, because we know that q is equal to 1 minus p. So what did we find? The variance of the binomial distribution. The variance of the binomial distribution is npq, whereas already we found that mean is np. Okay, these are the important properties we derived from the probability mass function of binomial distribution. Okay, now our mission is to calculate log. Let us see the variance. Here we could see some summary of variance, that is this is the formula. Okay, and you can calculate, you can decompose the summation here, and here you have written NCR as n factorial by n minus r into r factorial into r factorial. By using that you have reached up to this and you have gone for a substitution. X minus 2 is equal to y and x is equal to y plus 2, and simplifying you got the same step we got. Okay, n into n minus 1 p square into p plus q whole for n minus 2. Okay, now and here as we have seen, n square p square will be cancelled, and finally what we get, np minus n square np square, sorry, and np is out, that means 1 minus p, that is npq. So what we have proven? We have proven that the variance of the binomial distribution is npq. Okay, So by reading this into our mind, now let us try to calculate the log likelihood estimate of the binomial distribution, parameter p of binomial distribution. Let us assume that there are x1, x2, so on, xn, which are following binomial distribution. Okay, all the random variables are following binomial distribution with the parameter p. Now we want to find a maximum likelihood estimation of p. Okay, for that we are going to find log likelihood estimate of p. So this is what we understand log likelihood estimation of binomial distribution. Okay, now according to the definition of the maximum likelihood, it will be the product of I is equal to 1 to n all the binomial variables, that is xi comma p. We have n variables x1, x2, so on, xn. Now pi I is equal to 1 to n. What is binomial function? nc xi p power xi q power n minus xi. We have substituted the binomial formula ncx p power x q power n minus x. Okay, now I'd like to apply this is maximum likelihood. Now I'd like to apply natural logarithm on both sides. Now you know that the log, that means logarithm of the maximum likelihood, is called log likelihood function, that is small l. Small l denotes log likelihood and capital L denotes maximum likelihood. So small lp is equal to, when you apply log of pi I is equal to 1 to n nc xi p power xi q power n minus x. Okay. Now the thing is, log mn is equal to log m plus log n. You know this formula, log mn is equal to log m plus log n. So by using that formula, because this is a product, here product becomes addition. In the same way, here product becomes addition. That means summation I is equal to 1 to n log of ncxi. Okay, so log of ncxi, and log m power n is equal to n log m. So log ncxi is equal to log p power xi. Log p power xi is equal to xi log p, and log q power n minus xi is n minus xi log q. Okay, this is the thing we got under the log likelihood estimation of binomial. Okay, now what we got, log likelihood estimation of binomial distribution as summation I is equal to 1 to n 1 to n log nc xi plus xi summation runs from everything log p plus n minus xi into log 1 minus p. Okay, this is the log likelihood function we obtained. Now differentiate with respect to p. Now differentiate with respect to p. What we are getting, small l dash p is equal to here no p term we are observing. Here no p term means constant. So derivative of a constant is 0. That is why this becomes 0. And here we are observing log p. Log p derivative with respect to p, 1 by p. So xi into 1 by p. Okay, under summation I is equal to 1 to n. Plus here you are calculating, you are differentiating with respect to p. This is constant. Constant can be written as outside. And log 1 minus p derivative by using chain rule, 1 by 1 minus p. And inside derivative will be 0 minus 1. Okay. So what we got, L dash p, of course here the summation I is equal to 1 to n. Okay. Summation I is equal to 1 to n xi by p plus summation I is equal to 1 to n minus xi. Of course, this minus comes out, you can understand is a minus n minus xi by 1 minus p. Okay, this is L dash p. Now let us equate it to 0. That is summation, I am drawing a line here, summation xi by p is equal to summation n minus xi by 1 minus p. I is equal to 1 to n and I is equal to 1 to n. Okay. Now let us divide with n on both sides. We get x bar by p is equal to, summation n, for adding n for n times means here you are going to get and dividing with n means here you are going to get n minus x bar by 1 minus p. That means x bar minus x bar p is equal to np minus x bar p. X bar p is cancelled, that is mean is equal to n. So what we are observing in the general calculation of through E of x formula also, we observed that mean is np, and in maximum likelihood also mean is np. That means the maximum possible value for the parameter p binomial distribution is nothing but n into p, where n is the number of trials and p is the success rate for each and every trial. Okay, this is what we observed from log likelihood estimation of binomial distribution. So in this way, log likelihood estimation tells you that whether there is any deviation between the general E of x, that is general mean from E of x definition, and maximum possible limit of the parameter from the binomial distribution. So in order to know whether both are same or not, we can use log likelihood distribution. Okay. Now, before concluding the lecture, I'd like to share you see here how is maximum likelihood estimation is used in machine learning. Maximum likelihood estimation is probabilistic model based approach to determine values for the parameters of the model. ML is a widely used technique in machine learning, time series and panel data and discrete data. There are several applications of MLE in computer science, but we are interested only on machine learning. In machine learning, in a data set, when some features are missing, we will use some probabilistic model like binomial or Poisson normal to predict that feature. For that, we have to maximize the parameter. If binomial, it would be, if Poisson, it would be lambda, if normal, it would be mu, like that. We will try to find the maximum possible value, and the process is called maximum likelihood estimation. It helps us in machine learning algorithm to analyze the data and to predict the missing feature to the maximum possible extent accurately. Okay. Now, there are many techniques for solving density estimation, although a common framework used throughout the field of machine learning is maximum likelihood function estimation. Okay, that means there are several techniques, mathematical techniques used throughout the field of machine learning, okay, for solving density function. But in the field of machine learning, MLE is the best method. Okay, and MLE involves defining a likelihood function for calculating the conditional probability of observing the data sample given a probability distribution. That means when we are given a sample of probability distribution to fit the sample data, then in the maximum likelihood estimation, we will calculate conditional probabilities, which helps us to estimate the parameter to the maximum possible extent. This approach can be used to search a space of possible distributions and parameters. Okay, and a flexible probability framework also provides the foundation for many machine learning algorithms, including important methods such as linear regression and logistic regression for predicting numeric values and class tables respectively, but also more generally for deep learning, artificial intelligence, neural networks. That means there are several machine learning algorithms in reducing the or in predicting the dimensions or predicting features like PCA, principal component analysis, QR decomposition, as well. So many methods are there, but under regression methods, okay, logistic regression methods, okay, and but or maximum likelihood estimation has more important role in machine learning algorithms. Okay, that is what we are telling. Not only in machine learning, deep learning, because artificial intelligence contains machine learning as a subpart, and machine learning contains deep learning as a subpart. So maximum likelihood estimation is very important in probabilistic modeling of the given data. So that is why in calculating MLE, logarithm plays a very important role. That is why log likelihood estimation is very important. Okay, so these are the references which you could go through to find out these things. And with this, I'd like to conclude my lesson. And in the next class, we will meet with log likelihood estimation of another important probability distribution. Now I am signing off. Thank you all for your patience. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.